So in this video we are discussing 4-bit counter. Okay, so as previous video I have also created code, explain what is the circuit, then writing test bench, then we are simulating this. So similar process we will do in this video as well. So let's start without any delay. So our topic is 4-bit counter, and as you can see the number of bits is equal to number of flops. So here is 4-bit, so we also have our 1, 2, 3 and 4 flops, and this is our LSB and this is our MSB. Okay, so this is for your knowledge that counter look like this, and if I have made a digital electronics video for counter, then I will also explain that if counter is counting from 1, 2, 3, so in this manner, a perfect manner which we want, then there some combinational circuit also come here, combinational circuit, so which are included in between this. So this counter will not count properly, you can say, and but the main basic template is like this, and we will have like 0, 0, 0, 0 for 0, or if you want 1, 1, 0, 0, 0. So this is simple counter, but we are interested in more in coding. So here we will create our own counter. Okay, which is a 4-bit counter. So our output is 4-bit. Let's say C. We want our reset pin. One pin also I am including clear pin, and a most important thing, clock. Clock mostly done here. Okay. So these are the thing we needed for counter. So these are 4 pins and 4 things we need for writing a counter. Okay. So okay. So first of all we write module, then writing counter is the name of our module, then we are writing our signal, that is clock, then our first signal is clock, reset, clear and C. Then we have to declare this, and we will declare as input clock, because by default there is our wire, so we are not writing wire. Clock is clock, reset is reset, clear is clear. Okay, and output we are using bridge. Okay, and C, which is our 3 and 0. But now here one thing, if you are using unpacked array, so it will not have a single memory. Okay, it will have multiple, like 0 will be stored here, 1 will be stored, but we want our continuous memory because it is counter, right? So what we will do, we will not write unpacked, we will write packed array, because we want our memory to have continuous. Okay, because counting will be continuous. So we are using always block, always at the rate. Now here see passage of clock. If you want, you can write negage of reset or passage of. Okay, so what this mean, like it is first of all asynchronous code. So here we are using asynchronous reset as well as asynchronous clear. Okay, so at negage of reset means when reset is 0, it will be 0, 0, 0, and if it is passage of clear, it will be 0, 0, 0. Okay, so this thing we are included. You can also include set key or set pin, whatever you want. Like when set is high, then all of your inputs will be 1, 1, 1. So you can also include that. But for now, we are including clear. Okay. Now next thing is our begin, and then
hit subscribe, like, and comment now. Let's begin the journey of verification.
If reset, so we will writing not of reset, it is directly equal to, I will comment it, changing the color, so it will be equal to reset equal to 0. You can write like this. Okay, so reset, if reset, then C equal to 0, and this thing is directly equal to C is equal to 4 tick B000. Prefer to write this one, but for now I am writing this one, so you get both of the ideas. Okay, now else if our clear, then C equal to 0. Same thing, but here clear equal to 1. So this is the difference for writing this not. Okay, now else our main logic will be C equal to C plus 1 tick B 1, or you can write 1, or you can write 4 tick B0001, whatever you want. Okay, so C equal to C plus 1. This is our whole logic, and we will end the code like begin and end and module. Okay, so I hope you understand this code. It is simple code. I will explain once more. Like we are writing our if else, so focus on this. If reset is there, then C equal to 0. If clear is there, if reset is 0, then C equal to 0. If clear is 1, then C equal to 0. If nothing is like this, for then our with synchronous with our clock, whenever there is clock like this, our counter value will be like this. I will show you one, like 1, 2, with every process there will be a value 1, 2, 3, 4 like this. So this is this logic. So let's change pen for this one. Yeah. So module TV, let's say. So range will be as always our clock, reset and clear, which is wire in our module, and wire will be our C. And as I said earlier, we are using packed array. Fine. Now instantiation of module is important, so counter C, don't use count word is one keyword, so count will not work. So let's say C1, clock, reset, clear and C. So this is our initialization is over. Now writing our main logic, that is our initial, begin. So first thing is like being clock 0, so like clock equal to 0. Okay, now I will tell you a new thing. To write repeat, begin. So first you have to give number, let's say 10, begin, and I am writing clock equal to negative of clock. So it will generate clock for 10 times. It will be like this and this. Okay, so this thing is like this for 10 times. So 1, 2 up till 10 times. Okay, so clock 0, then it will toggle. So this is one new thing. Mostly I don't use this. Mostly write always block for generating clock. For your better understanding, I am also giving you another option for testing simple things. In Testbench, which we are simulating, I have created clock with always block. Okay. Now next thing is we are giving, after let's say 10 nanosecond or 10 unit of delay, we are giving reset equal to 0, which is low. Then reset equal to 1 means we are again counting. Okay, so you can again write this thing, and also you can write clear equal to 1. Then after 10 clear equal to 0. But if you are writing repeat, you have to include this thing here, then again you have to include this thing here, then again you have to include this thing here. So 10 times the clock will. If you write directly parallel to this initial block, one another always block with okay, let's say, and so if you are writing like always at the rate #5 clock equal to delta of clock or negation of clock or not of clock, whatever you want. So this will generate a 5 nanosecond, means this will equal to 5 and this will equal to 5. So total time period will be of 10. Okay, time period will be of 10. And this is our process, this is our process. So this thing you can do this, or you can write it repeat loop if you want, whatever you feel you can do this. And lastly, and module. So let's check on our code if there is any mistake or anything I have missed. For now I don't think I have missed something. Yeah. So let's go for our simulation. Asynchronous reset, asynchronous, and here I have used both POSIX, and similar to that reset I have used this and this and this. So what I have used in my code is our blocking, and here we are using non-blocking. So for sequential circuit mostly use non-blocking, okay, but you can write code with blocking also. But the problem is with blocking, it will give you a trace around condition, and some issues are there with the blocking. So I will recommend you to watch the video for blocking and non-blocking, difference between blocking, non-blocking, and regions of operation in Verilog. So yeah, so you can watch the video, then you will understand this thing. So I have included both code, and it is not wrong, but most prefer to write this non-blocking for sequential circuit. Okay, now here is our time scale, 1 ns by 1 ps, so 1 nanosecond will be there for delay. Okay, and here is our clock reset and everything, which I have already told you. There it is our named instantiation. Previously we used position instantiation, and this clock which I have explained you previously, and if first we are doing it 0, then we are changing it. Okay, and dollar finish, because we want to stop this always block. Okay, if you write repeat, then there is no need for dollar finish. This go from 0, 1, 2, 3, then again some reset or clear has come, then again 0, 1, 2, 3. Okay, so this is our clock, our 5 nanosecond, which we are using for controlling this our counter, which is our 4 bit. Okay, thank you.
Please Lord give me a sign, a sign.